Hey guys, today we're going to do 15.5 notes. This is the last section of Unit 15. We're going to discuss arcs, semicircles, and central angles. First, we need a little bit of content. Central angle is an angle whose vertex is at the center of a circle. It separates a circle into two arcs. The sum of the central angles is 360 degrees. So the theorem technically says the sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. Okay. So example 1, let's identify the central angle. Well, if it has a vertex at the center and it cuts it into two arcs, there's an arc and there's an arc, angle LEY is the central angle. And then the two arcs. Well, one arc is arc LY, and then the other arc is arc LUY. Notice the arc symbol. We have two different categories of arcs. First, we have a minor arc. A minor arc is an arc with a measure less than 180 degrees. And it's named by its two endpoints. So the minor arc above was arc LY. Then we have a major arc. Major arc is an arc with a measure greater than 180 degrees, and it's named by its two endpoints and another point on the arc. So the arc above, arc LUY, is a major arc. Arcs are measured by their corresponding central angles. Okay, so what that means is whatever the measure of the central angle is, the arc that matches it will have the same measure. So, knowing that, let's look at example 2. It says find the measure of angle PCM. Well, we're given angle PCM is 110 degrees. So that means that arc PM, which corresponds to that central angle, is also 110 degrees. Well, we need arc PNM. Well, if this arc is 110 degrees and all the way around is 360, so 360 minus 110 will give us 250 degrees for that major arc PNM. What kind of arc is arc PM? It's a minor arc because it has a measure less than 180 degrees. All right, let's move on to the next page. Semicircles. Semicircle is an arc with a measure equal to exactly 180 degrees. It is formed when a diameter separates the circle into two congruent arcs. Okay. So let's go into example 3. Example 3 states, in circle E, the measure of angle AEN is 18 degrees. Segment JN is a diameter, and the measure of angle JES is 90 degrees. Find each measure. All right, so the first thing I'm probably going to do is I'm going to fill in what I know on my picture. So AEN's 18 degrees. JN is a diameter. It's awesome. That means that is a semicircle and that's a semicircle. And JES is 90 degrees, so there's a right angle there. Find the measure of arc AN. Well, it corresponds to central angle AEN, therefore it's 18 degrees. Find the measure of arc JA. Well, all of this, JAN, is a semicircle, which is 180. So 180 minus 18 gives us 62 degrees. And then finally, JAS. Okay, JAS. Well, this was 90. The whole thing's 360. So 360 minus 90 gives us 270 for J. Always follow the letters. JAS. That arc right there. 270 degrees. Okay. All right. Example 4. So example 4 is pretty long. I want you to go ahead and pause the video and see if you can try to get example 4. So hit pause now, and then when you think you got it, hit play, and then I'll talk you through it. All right, let's see how you did. So arc AB corresponds to that central angle, so it's 45 degrees. Arc AD, okay, so since it's 2, it's a minor arc. So this one's a little tricky. So I'd have to take 360 minus 45 minus 90 and minus 85, and then that would equal 140 degrees for arc AD. Okay, arc AC would be 90 plus 45, which gives me 135 degrees. Arc BC corresponds to a right angle, so it's 90 degrees. Then we have arc ADC. Okay, so we got arc ADC. All right. Well, we need to figure out what this angle is and this angle is and add those to 85. All right. So one thing that we need to remember is this tangent is 90 degrees. Okay. So if we do 90 and 38 from 180, that'll give us 52 degrees. Okay, and then in order to get that missing angle, I'm going to do 360 minus all the other central angles that I know, and that's 88 degrees. So I'm going to add 88 plus 52 plus 85. Give me ADC is 225 degrees. And then ACD is 45 plus 90 plus 85 is 220 degrees. And then finally we need arc AED. Since that's 52 degrees, that central angle, then that arc is 52 degrees. And then arc AE, I've got that central angle, makes it easy, 88 degrees. Measure of angle DOF. We've got that one, 52 degrees. Ooh, it's a terrible 5. And then angle EOA, 88 degrees. So hopefully you were able to get some of those. It's a little tricky, but not too bad. But you guys can handle it. You're pretty smart. All right, last example. Example 5 says find the measure of each of the following. Okay. Well, notice we have some x's, so the first thing we're probably going to need to do is figure out what x is, the value for x. So all the arcs are labeled with expressions that have x in them. Well, all the arcs add up to 360 degrees. So to solve for x, I'm going to write an equation. And set it equal to 360 degrees. I'm going to solve this equation. So I need all my x's. So I've got 3, 4, 8, 10 x's, combining like terms. Got 15 and 15 is 30. Subtract 30 from both sides, and I get 10x is 330. Divide by 10, x is 33. Okay, so So then probably the next thing I would do is just write on my picture what everything is. So x is 33. 4 times 33 gives us 132. 2 times 33 plus 15 means that one's 81. 3 times 33 plus 15 would give us 114 for that one. And then we can just simply answer the questions. AOB, 33 degrees, corresponding arc. Angle BOC, 132 degrees. Angle COD, 81 degrees. And finally, angle AOD, 114 degrees. Okay. So hopefully that made sense. If it didn't, just make sure you ask questions. Go ahead and do your assignment for 15.5 and hope to see you guys soon. Bye.